equation, this function, and to be a function, we know that the x has to have one and only one y assigned to it. So that series of equations there has to make that still be true. And a piecewise function says you have pieces of equations to use. Not actually the equations, but of what piece of your domain is going to fit those equations. So a good way to start this is just number these pieces, 1, 2, and 3. And we're going to make a table for 1, 2, and 3. What's restricted here is the domain. This is what gives us the pieces. This is called your restricted domain area. And the domain is the allowable x's that we can use for that function, for that piece. This is why it's piecewise. It's kind of pieced together. You come up with something that is a function. It doesn't look smooth and continuous all the time. It looks kind of choppy, but it still is a function. So according to this, if we take a look at your number line, from 0 on down is the domain that you're allowed to use for the first one. So in other words, any negative numbers, and then stop at 0. So -3, -2, -1, 0. Don't go any further past 0. Okay? The next thing you want to do is determine, is that 0 opened or closed? So because it has an equal sign, it's going to be closed. Make a little closed dot right there. The second one says, oh, you're allowed to use from 0 to 2. You can't use the 0, but you can use the 2. So I want all the numbers between 0 and 2. 0 is open, 2 is closed. So for that little segment, I'm going to use that domain and all the little numbers in between them. Now your third one says greater than 2. Greater than 2. This has to be open. So greater than 2 says 2, 3, 4, 5. I can use any of these. Always start and end at the one that they specify. Now this 2 is open. So if you take a look for a second here, even though we use the 0 twice in 2 different functions and they may be different y values, this one is closed, this one is open. It's going to make a function. This 2 is closed, this 2 is open. It'll make us a function. One of them's allowed to use it, one of them's not. One's open, one's closed. Now, because this is the same as y equal, there's a y equal 4. There's a y equals 4 minus x squared. There's a y equals 2x minus 6. You can put this in your calculator and then just go to this part of the table, the restricted domain part. So in my line y equals 4, I only care about from here on down. And so what is the value of y? 4. It's a constant line. Okay? This guy, what is this piece of what is that function doing? What is that function? Parabola. Which way is it opening? Down. Okay? And it's got a little translation here. It's got a parabola open down and it moved up 4 spaces. So if I put this in my y equals and I just look at this part of my table, I'll find my corresponding y values. Or, because I only need a few, I can substitute it in. 4 minus 0 squared is 4. 4 minus 1 squared is 3. 4 minus 2 squared is 0. You'll find those in your xy table. Right? If you graph that in your y equal and you just go to that restricted piece of domain, you'll find those y's, right? Okay. Now, from 2 on out, we can use in this function. And what's that function going to give us? A line. Good. This will give you a line, a linear equation. So if you put that in your y equals, go to your table and pull this out, or do your substitution. 2 times 2 is 4, minus 6, negative 2, and it's a line, so it's going to increase. 6 minus 6, 0, it's going up by 2 because that's your slope. 2 and 4. These are the pieces to your graph. These are the piecewise functions. One of the hardest things to get used to in precalc is a sketch. We sketch. We don't use your grid any longer. We sketch. So if we're going to sketch these pieces, we're going to kind of have to figure out where they go. Now, your first guy says from 0, all your negatives, your y is 4. So 0, 4, this is the important dot right there, 0, 4. And your line is going like this, watch. Negative 1 is at 4, negative 2 is at 4, negative 3 is at 4. It's going like this. Sketch. Okay, that one's going on indefinitely because we were told anything up to the 0 you can use for x. Now, the second piece of it, you're using the 0, the 1, the 2. At the 0, you're a 4, but this time you're open. You're not allowed to use it, right? At the 1, you're a 3. At the 2, you're a 0. Closed. So you went from here to here. See it? You used all the pieces in between. Yeah? Okay? Now, the last one, you're making a line again. It's a linear equation. Start with your 2 at the negative 2. And this guy is open. 3, 0, 4, 2. See it? It's a line. Here's your piecewise function. It's still a function. If we drop a vertical line test, then when this one's open, that one's closed. When this one's closed, that guy's open. It passes a vertical line test. We piece together 3 different equations at once, based on the restricted domain. Based on the domain that just that equation was allowed to use. See, it doesn't always look like nice, like you say, oh yeah, I get that graph. And I'm throwing another thing at you, sketching. You can still visualize where your points are, but you're going to get more of a habit of saying, okay, oh yeah, from here to here, I drop down, there's my parabola. From here to here, up, there's my line. And you'll get good with the sketching part. I think the easiest way to do this is with your 3 tables. Set your domain up, and then work each individual piece. It's very hard to visualize this without your tables. Questions on this? No? All right. Let's try another one. Okay. Okay. All right. Here's another piecewise function. f of x says this is a function. It's going to use 3 different types of equations with 3 restricted domains. These are your restricted domains. You're going to label 1, 2, 3, and make 3 tables. Okay. This first domain, picture your number line, if you will. It says from negative 2 to the left. So I got to stop at negative 2. So just give me a couple, like negative 5, negative 4, negative 3, negative 2. Don't go past the negative 2. Is it opened or closed at negative 2? Open. Good. There's no equal sign. Now, the next one says go from negative 2, can use, to positive 2, can't use. See that little piece of restricted domain? Negative 2, negative 1, 0, 1, 2. This negative 2 I can use, this positive 2 I can't use. So do you see your negative 2's right now? This guy's open, this guy's closed. Good so far? Alright, and now your last, get all your domains first. Your last domain says from 2 to infinity. See look up at your graph, see all your domain is being used. Your domain for this whole function is all real numbers. But we gave you segments to do, pieces to do. So you're going from 2, where you can use this, to 3, 4, 5. Okay? Now, plug these in. Again, you can set up your y equals for each one of those. It's a line, and it's sloped to the left. So, or you can substitute in if you like. Negative 5, a negative of a negative is positive. This will be a 3. A negative of a negative is positive 2. Seeing it go down 1, because look at your slope. Your slope is negative 1. 1, 0. That's as far as we need to go. For your second one, there's one of your restricted radicals. You got a quadratic under a radical. So you can graph that part, the function. You can graph that, or you can substitute in. We should see this. This is a parabola underneath here. We should see part of your parabola for me. Negative 2 squared is 4. 4 minus 4, 0. Negative 1 squared is 1. 3. Radical 3. Radical 3 is about 1.732. So 1.7-ish somewhere. 0 will give you square root of 4. 2. 1. See the symmetry here? Here's your radical 3. Here's your 0. So you kind of get the effect of, remember what, like sometimes we use the in between, sometimes we use the or, the and. We had a radical underneath that. And the last one, this is another line. A line with a positive slope, so plug in a 2. 5. You're only going up by 1s each time. So 6, 7, 8, and so forth. So we have your 3 pieces, and we're going to graph them. We're going to sketch. The first part says you're going to stop at the negative 2. Negative 2 is 0, and it's open. Negative 3 is 1. Negative 4 is 2. See your line going that way? There's your line. If I continued it, it would cross here at the negative 2, just like this says.
Is there a reason why it's not like flowers?
Because that's where it ends. So I kind of like to start where it ends. You can start it. Like, this is going on and on and on for whatever. So you can start at the negative 5 right here, but just remember, this one is the one that's going on and on. I think if you look at your number line with your domain pieces, it kind of helps you there as well. The second part, negative 2 is 0. Oh, that's filled in now. Negative 1 is 1.7. 0, 2. Here's your symmetry. See it? Open. So this was filled, and this is open. Here's your parabola. Turning. And your last piece, the 2 is at 5. Closed. 3 is a 6. 7, 8. It's a line. Here's your piecewise function. So you say, is this a function? Yes, because every x has 1 and only 1 y. And we can see on our number line up here, I think this is very helpful, this piece right there. It's very helpful to keep that piece right there. Questions on your piece bars? We did this in Algebra 2. In Algebra 2, we used our grids. We used our tick marks to help us out too. So in pre-calc, we're sketching rather than worrying about the actual grid marks. But what's important are these endpoints. These endpoints are what's important because that's where they overlap. Okay? Questions for the class group? No? So you have 6 of them to do, Kristen?
So you leave that circle open even though like that one's closed.
This one, yeah, you kind of have a double thing. You kind of have an open with a closed in it.
That's what's happening.
Well, you kind of just make it so that you can see that you opened it and closed it. It's kind of like a bullseye effect. I try to do this, open, close, so that you can see it has an open and a close. Otherwise, you have to kind of look at your table.